Hi, fifth graders. This is just a little introduction to fractions. You've learned this stuff before, and so you'll learn it again. Okay, when a figure is divided into equal parts, and that is important, every one of these pieces right here, they're the same size, and that's definitely necessary when we're talking about fractions. The pieces have to be the same size. When a figure is divided into equal parts, you can write a fraction to show what part is shaded. 3 of these parts are shaded, so you put a 3 on the top. That 3 is called the numerator. The numerator goes on the top, and then you don't put 7 on the bottom, you put 10 on the bottom because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts all total. And that number on the bottom is called the denominator. So numerator over denominator. This number represents the part that's shaded, and this represents the whole thing. Okay, so here's a question for you. What if all the parts of the rectangle were shaded? What fraction would you write? So if all 10 parts were shaded, that would be 10 parts shaded over 10 parts total. Hi, fifth graders. This is just a little introduction to fractions. You may want to take some notes on this. When a figure is divided into equal parts, and notice this figure is divided into equal parts. Each one of these rectangles is the same size, and that is important in dealing with fractions. So if it's divided into equal parts, you can write a fraction to show what part is shaded. For example, 3/10, the number of parts shaded, 1, 2, 3, that's where we get 3. And the total number of parts, notice that it's 10, it's not 7. It's 10 because there are 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the part over the whole. There's a math word for each one of those things. The top of the fraction, let's try that again. The top of the fraction is called the numerator, and the bottom of the fraction is called the denominator. Okay, so here's a question for you. What if all the parts of the rectangle were shaded? What fraction would you write? Well, the shaded part would then be 10. The total number of parts would still be 10. So you would have 10 over 10, or 10/10. And then the question is, what whole number is this equal to? 10 over 10 is 1. Pretend this is a cake. If you get all 10 parts, if all 10 pieces were shaded, you got 10/10, but you also got one whole cake. So any number where the numerator and the denominator are the same is equal to 1. Next question. What fraction would you write if none of the parts were shaded? Well, none, of course, is 0 out of 10. And then same question, what whole number is this equal to? Well, if you got 0 out of 10 pieces, it doesn't really matter how many pieces there were. You got 0. And that's the whole number that it's equal to. So any fraction that has 0 on the top is equal to 0. Question number 4 asks, what if you shaded 4 parts? What fraction would you write? That would be 4 out of 10. And they'd like to make a connection here between fractions and decimals. If you just read this fraction, it says 4/10. If we were doing a decimal lesson and I said write 4/10, you would write 0.4. You've got the 4 in the tenths place. So those two things are equal, 4/10, or the decimal, 4/10. You can write a fraction to name a point on a number line. Now, what I want you to see first is we've got 0 right here, and this is really 1 right here, okay? And so all of this space in here, it's just the distance from 0 to 1, okay? And it's divided into 8 equal pieces. So there are 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. So each one of those jumps is equal to 1/8. So point A is 3/8 because there are 8 sections. That's the denominator. And when starting at 0, it's 1, 2, 3 jumps to get there. For 5/8, it's 5 jumps to get there. 1, 2, 3, 4, 5. So the next question is, what number, what fraction goes with point C? Again, start at 0. 1, 2, 3, 4, 5, 6, 7 jumps to get there. And the denominator is, the numerator is going to be 7, and the denominator for all of them is 8, because there are 8 total jumps to get from 0 to 1. It has been divided into 8 equal parts. Okay, here are some questions for you to answer. What part of the set of squares is shaded? So we have a set of things here, and there are 3 members in the set, and 2 of them are shaded. So you have 2/3 that are shaded. Number 7 has one thing, but it's divided into 1, 2, 3, 4, 5, 6 parts. So that's your denominator. And 4 of them are shaded. So your answer for that would be 4/6. And I know some of you, especially parents out there, are wanting to call that 2/3, but we're not there yet. 4/6 is the correct answer for now. Okay, now we've got another one of those number line questions. Remember, the number line is broken up from 0 to 1, and we need to know how many jumps are included in there from 0 to 1. So starting at 0, 1, 2, 3, 4, 5, 6 jumps. So 6 is going to be our denominator. And how many jumps to get from 0 to D? I think that's pretty obvious that that's 5. So our answer there would be 5/6. Number 9, write the fraction for the part that is shaded. If you count up those stars, we've got 12 of them, so that's the denominator, and 5 of them have been shaded. Number 10, we've got 9 circles, and 5 have been shaded. Number 11, there are 10 pieces of pie, let's call them, and 6 of them have been shaded. Number 12, there are 5 parts to that rectangle, and 4 of them have been shaded. So just basically naming some fractions. Okay, for number 13, we've got another number line question. How many jumps from 0 to 1? 1, 2, 3, 4, 5. Denominator's 5. And E is 2 jumps, so 2/5. How many jumps from 0 to 1? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got ninths and F is starting at 0, 1, 2, 3, 4, 5, 6 of them. So 6/9. Then we're asked to write the fraction. 1/2 looks like that. 3/7, 7/12. I think we could do this all day. I hope you can. 18 is 9/10, 10/11, 17/20. Okay, those are pretty easy. Well, now they're throwing decimals at us again here. What does that one say? That 8 is in the 10th place, one digit after the decimal point. So that says 8/10. 8/10. This 3 is 2 digits after the decimal point, and that would be the hundredths place. So 100 is the denominator, and 93 hundredths. Then number 23, the last digit is in the thousandths place. So we're going to put 1,000 on the bottom and put 415 on the top. Number 24, the numerator is 2, the denominator is 9. The numerator goes on the top, the denominator goes on the bottom. Number 25, the numerator is 8, the denominator is 15. Pretty straightforward. Okay, more decimals. I want you to take the fraction and turn it into a decimal. 9/10 is a 9 in the tenths place. Put a 0 there to make it neat and pretty. Number 27, we need 12 to end in the hundredths place. Hundredths place is 2 digits after the decimal point, so our 12 goes right there. Put a 0 here to make it good form. 2/10, put a 2 in the tenths place. Put a 0 here for good form. This one's a little bit trickier. 9/100. The hundredths place is 2 places after the decimal point. We only have 1 digit, so it has to go there. And this empty space needs to be filled with a 0. And then that 0 makes it good form. So that says 9/100. Number 30, 56/100. We need the last digit to be 2 places after the decimal point, which works out nicely with 56. Put a 0 here to make it good form. Number 31. There are 25 students in Martin's class. 8 of them belong to the Model Airplane Club. What fraction of the class are club members? Well, 8 is the part, and 25 is the whole, so 8/25. This one, I don't know the exact count, actually, of boys and girls in your class. You can figure that out yourself if you want to.